handle this, yeah? All right. All right, so fluid mechanics. What comes to mind? I had some good reviews. Okay, do I need to introduce myself? No, yeah? We have already met. We are familiar. Who? Fitmir? I don't know that brother. I don't know. Okay, so 112. Yeah? So fluid mechanics, or simply put, just hydraulics, huh? So terrible at writing. So, first thing is first. So we have agreed that we'll be meeting today, which is a Tuesday, just for 1 hour. And then we need to find another day, according to, who's the class rep who sent me this? Where's Mufasa? Huh? He's in traffic. Ni hustler. Okay. So we're talking about, so Tuesdays, so from 17 to 18, and Thursday? Okay. So, and I'm talking about us meeting the way we're meeting right now. Thursday, and at the same time. Right? Okay. So the next thing that I want you to agree on is, do we have the module for fluid mechanics? No. Have you made an effort to find or look for? So you haven't found it? Some of you have? And you guys have got a WhatsApp group, not so? So share it there. But then also, class reps, after this, just WhatsApp me before 19 hours. If it's after 19, don't WhatsApp me, yeah? So that I send you the module. Okay? So just to give you a little general view of this course, because it always helps to understand what you're dealing with. So one, it has a lot of calculations. So if you hate calculations, well, it's not so bad an idea to quit now. Yeah? So it's got calculations. It's got a bit of it that requires you to explain one or two things, concepts. For instance, you've heard of the Bernoulli's equation? No? Yes? Cool. You've heard of the YouTube manometer? Okay, so this is me just giving you a general view. So overall, where an exam has been set, you usually find about 70% of them are calculations. And then 30%, well, just describe, state, maybe explain, differentiate. Can you discuss? Are we together? So know that. Two, what I always advise students, I was here as a student, and I think I mentioned this when we met last semester, not so. NRDC, well, to be honest, I've been at UNZA, it's not that different. What you want to do for you to just help or get to the next level of, just studying and understanding what you're doing. When you go to a new environment, new course, find the past papers. Because when you go through a past paper, it gives you an idea of how that exam is going to be set. And you don't have to find that exam paper and start solving, no. Just perusing, okay? Just read through, just look, okay, this is question 1. This is section A, they're asking for this. Those questions are very similar. What that will do is that when you begin learning and studying on your own, it will just be clicking, oh, I think this statement here relates to that question that I saw. It's much easier to study like that, unlike just studying as though there hasn't been prior, papers, yeah? So find the past papers, and this applies not just to fluid mechanics, but to the other courses as well. And from time to time, you find me just talking about just the general upkeep, because I really feel like you guys are my young brothers and sisters. 2010, where were you in 2010? Sir, where were you in 2010? Grade 1. I'm officially old, like really old. 2010, I was here in first year at NRDC, meaning I had done grade 12. Then that's when I came here. Okay, so from time to time I'll be telling you of, you want to keep quiet, we're only here just for less than an hour. There are things that I always try to do is, I try to be the change that I wished was there when I was seated in your position. So I tell students the realities of the industry. I tell students what is expected of you and how you can just thrive when you go out there. To start with, who knows what Zawafe is? Zambia Water Forum and Exhibition. Exactly. You want a job? Do you want to get exposed in your industry? Network with the right people. So there are many forums, there are many platforms, there are many events that usually happen around Mulungushi, and most of them are actually free. If you are hoping that, oh, nikasiza skuru, nizashita apply kuboma, 1% chito, guys, things are tough. One, learn to network, learn to move around, know people, interact with people. And when you go to events that are talking about your career or your path, you stand better chances. Are we good? All right, cool. I need to get me a book. So no one has a module here. All right, introduction to fluids. All right. Introduction to fluids. So intro to fluids. So what I usually do is I just guide students on how to use the material. If you have a different fluid mechanics material that you can use it. But usually I just try to get the most important or catchy concepts from the module. And then at your own time, you find time to just go and study that further. You want to keep your phones a bit silent or just off really. Okay, so by intro, we're going to sort of define. So some things I'll be asking you to, I'll be dictating so that you can write. Then others you can find time when you're studying just to do that. So 1, there are 3 states of matter. Also, I repeat something 3 times. If you don't get it, look next to you. If they haven't gotten it, well, you have the module you can always go back to after this. So there are 3 states of matter: solids, liquids, and gases. There are 3 states of matter: solids, liquids, and gases. Last time, there are 3 states of matter: solids, liquids, and gases. So write that just as a bullet. And I know we know these things because we've heard of them before, but it's just important to just refresh and be sure that what we learned in that high school is what still applies here. Bullet number 2, both liquids and gases are classified as fluids in this course. All right? Both liquids and gases are classified as fluids just for this course. I'll repeat that one more time. Both liquids and gases are classified as fluids. So in academia, what's one word means for the other course is not the same as the next course. Are we together? So don't get this definition that says gases and liquids are classified as fluids and take it maybe to hydrology. It won't work because they've got their own terminology there. So for fluid mechanics, when we are discussing, so from time to time, I'll say a fluid, and sometimes I'll say a gas and a liquid, and I'm just talking about the same thing. All right. Then the other bullet points, you do have these guys. So I'm just going to read them out. You don't need to write them. Liquids may have or may be considered to have a fixed volume and therefore can have a free surface. Liquids are almost incompressible. All right. Do we know what that statement means? Liquids are almost incompressible. What does that mean? Anybody? Yes, sir.
Like it cannot be compressed, it has to be brought together. The moment you bring them together, you just change in shape.
Okay. Anybody else? When fluids or liquids are incompressible, what do we really mean? Okay, let's define what a fluid is. So we have introduced, let's try to define what a fluid is. This is a very important description. A fluid is a substance which conforms continuously. A fluid is a substance which conforms. A fluid is a substance which conforms continuously under the action of shearing forces. I remember someone mentioning they read shearing force. Huh? A fluid is a substance which conforms continuously under the action of shearing forces. Shearing. You know what it means to shear, not so? A shearing force. What's a shearing force? Is this the first time we're hearing of the terminology? Let's say shearing force. Yeah? Yes, sir.
So this shearing force is a type of force which is parallel to the material, which can bring up the formation or tearing of the same material.
Hey, this brother is studying now. So the rest of us are just are jamming to the big speaker. Talking about the speaker, have you guys come back with that big speaker I'm always hearing? Last time you said it was loud, extremely loud. Who's the owner of that speaker?
It's coming again.
It's coming again. Yeah, I'm organizing people to steal that speaker. You guys, whenever having a function, I'm not sleeping on time. Last time I think you had a function there, still. Taka mpelekane ku road kuja side. Maybe. Okay. So some things I'm leaving out, it doesn't mean that they are not important. They are, except for academic purposes and for you to clear this course. There are those that I know this from time to time shows up in an exam. But you find that the points that I'm touching on are always related to some things that I may not have really talked about here. Sometimes they design materials in a way that they will talk about just one point and they'll spend about 10 pages, okay, which is just a sheer waste. Huh? Yeah, but it's important, and they do that because everyone sort of understands things differently. So they'll explain something once, and then they'll need to explain it a different way to somebody else. Okay, another subunit, units. Apana fluid mechanics karibu no yambaye. So units are very important in engineering, not just in fluid mechanics. And I would like to think that at one point or the other when we were in high school, our teachers were always furious if they say if you're adding 2 apples plus 3 apples, what do you have? You can't just say 5, huh? So they'll say 5 what, you know? So it's the units. Even in engineering, it's very important. If you're measuring volume, you will say it's 10, maybe liters or 10 cubic meters. And so we want to fully understand what those units are. So in fluid mechanics, there are what we call unit free and SI units. I do not like writing. So now I'm being forced to do this. Okay, so let's just have this table because it's really important and it's going to help us understand whatever is coming on. So it's what we call SI units. All right. And unit free mass. So when you're going to have a dimension, okay, what should be the symbol? This is under unit free, but then when it's in a unit, a SI unit, you're going to have what we call a unit and a symbol. So this may not really make sense to you right now, but as time goes, as we begin, especially calculations, these things are really going to come in handy, okay? So one measure of, or one unit of measure that is really important to us is mass. And when it is unit free, the symbol for mass is just an M, all right? We also have a unit free of length, and when it is unit free, it is just called a length. So what I mean is this laptop has got a mass of so much, all right? So when it doesn't have a unit, it's just called just a mass, and it's symbolized by that way. Remember, mass can have different units. It can have kgs, it can have ounces, no, it can have pounds, like most of the Americans would use the symbols, not so. But usually in Zambia, we keep it to just the kgs, yeah? Okay. For distance, it could be length, and when it is unit free, it's just going to be an L there. And then time, when it's unit free, it's just a letter T. Temperature, unit free, you've got that symbol over there. What symbol is this? It's a Greek symbol, not so. But when you go to the SI units, and these are the most important units, usually you want to always have a symbol or a unit for everything and anything that you're doing. So for a kilogram, you have a symbol of just a kg. For length, you're going to have a meter. And this is just symbolized by a small case. Don't mix these two. And then when we have time, the unit is a second and symbolized just with that S. And then for temperature, we have Kelvin, and it is symbolized as a K. So this table is linked in some way to everything. So when you talk about mass, when it is unit free, it just got that capital M. But when mass has got a unit, it is called a kilogram, yeah, or kgs, and the symbol is kg. The same goes for length. If it doesn't have a unit, it's just L. If it has a unit, you're going to call it a meter. So you can't call it a centimeter. That's not the SI recognized unit. Are we together? All right. The same goes for mass. You can't say pound. For the SI units accepted, they're kilograms. Time is the same. All right. So, and then it goes that way. Some of these are just easy for you guys to learn about. Prefixes. What are prefixes? What's a prefix? Who can give an example of a prefix? Yes, madam. Okay. That's a prefix, not so. Any other prefix that we know? I don't even need to talk about this. What's the other one? Tera. What is the prefix there? The multiple of the prefix. Tera is a what? So like terabyte, not so. Terabytes, gigabytes, nanobytes. They're also nanos, not so. Okay, which others do we know that are famous? Mega. What is a mega? It's a what? What's a mega? Because I can hear people are just mentioning, but they don't really know what they are. 10 to the power 6. Okay. So a tera we said is a what? 10 to the power 12. Giga. A deci. Not really. A deci, again. But it's a negative, you're right.
10 to the power negative 4.
A deci. D-E-C-I. To the power negative 3, yeah? So it's sort of the opposite of like a kilogram. All right? What's a deca? 10 to the power 1. All right? So there are a lot of them. There's pico, 10 to the power negative 12, nano, 10 to the power negative 9, a micro, 10 to the power. What's a micro? Negative 6, huh? So, as you are studying, pay attention to the prefixes. Why do you think prefixes are important in engineering? Why do you think it's just important to do that? Yes, madam.
It's the easiest way to represent big numbers.
She's right. Okay. So, for instance, I have got a 2 tera. Okay, 2 terabytes. 2 terabytes. The other way I can write this is just literally 2 multiplied by 10 to the power, it's a 12, yeah? Okay. But then this is also a scientific way of writing. So if you're not taking the scientific route, you're literally saying 2 multiplied by, how many zeros are you putting here? There are a lot. So usually when you're bidding, when you become those certified engineers and you're bidding for roads, you're presenting your bids, you're presenting what you can do so that you can win that contract, that tender. How you present the information says, oh, okay, these are engineers and they've done this work before because they're presenting the information in a certain way. So you come and write 2 multiplied by so many zeros and it's going to show that, oh, okay, we may not really be dealing with someone who's knowledgeable. So it helps us just to represent the information in a way that is 1, professional, 2, easy to bring to the table, and then just for being efficient really with your writing that information. So find time to read more about that. Section page 21. Okay, let's do some interesting stuff now. Yeah, it could be a calculation. So, there's what we call properties. So these are fluid properties. Properties. I hope this is showing on the board there. Okay. There are three very important properties of fluids, and these properties, they will come back every now and then through each and every topic that we're going to have going forward. All right? And so it's just very important for us to have them. So property number one of a fluid is mass density. Mass density. Hey, zaoneka video hii. Hello? Yes, sir. I'm okay, sir. How are you? Okay. Where are you at the moment? Come to NRDC, the campus. Mm-hmm. Okay, okay. Okay. Mass density. So there are properties, like I said, there are many properties that you can find in a fluid. So whatever fluid you are presented as an engineer, you need to understand what is the mass density. The next one that you need to understand, we're going to talk about it. How do we define what mass density is? And these properties, remember, they come back in this topic. They're coming back in the next other topic up until you're done. So if you miss it now, here, it really becomes hard for you to go back and just fully understand everything. So understand these properties. All right? So let's write this under mass density. The mass per unit volume of a substance, the mass per unit volume of a substance, the mass per unit volume of a substance, usually denoted as, what symbol is this? So that's called, that's rho, okay? It's also a Greek symbol. I think it's written as RHO. It's rho. And it's used to represent the mass density of a fluid, okay? It's denoted as that. So in other books, they'll really curve it, but others, they'll just put it in a slanting sort of P mode. So just know what you, yeah. The other thing that I can say about mass density is that there are fluids that are very common whenever we're doing fluid mechanics in this course. And it is very important that you know which those, fluids are and what their properties are. So for mass density, you want to know at the, tips of your fingers what it is for water, what it is for mercury, for air, and paraffin. So let's begin with one. So let's start with water. So the mass density of water is 1,000. What are the units? It's grams per volume. Again, we're using the SI units. Kilograms, the SI units, meters cubed. Are we together? What is the mass density for mercury? Why not? Okay, for mercury. So for mercury, it fluctuates, but it's around 13,546 kg over a cubic meter. Are we together? And then we also have for air, we also have for paraffin. My point is, each and every fluid has got its own mass density. And particularly for this course, you're expected at least to, for lack of a better term, to memorize what the mass density of water is, what the mass density of mercury is, maybe air and paraffin. It's for your own good. So what happens that sometimes in an exam or a test, we want to give you the value of water. And so we expect you to still have a value which is around what is in the module. Are we together? Another, property that is very important for fluids and in this course is what we call specific weight. Okay, specific weight. What is specific weight? Let's define what that is. The weight of a unit volume, the weight of a unit volume, the weight of a unit volume of a substance, usually denoted as, I think this is gamma, so denoted as, is that gamma? Huh. All right. And I know we have different handwritings all over, but whenever you're presented, just let it look a bit like that. So that represents the specific weight of a liquid. All right. And how does this specific weight relate to mass density? Because from here, that's what we're getting to. If you are given one property of a fluid, how can you get the other properties from it? And already the calculations begin. So it starts with you knowing the relationship between mass density, the relationship between mass density and specific weight, and the other one, and how they are related. Because the next exam, test, or a quiz, you'll be given one, and how do you get the other one? Are we together? So how they relate is, so again, know this formula, mass density by gravity. That's their relationship. The gravity is the gravity as we know it. And at NRDC, we stick to a 9.281. 9 point, what? That did not sound right. So at NRDC, our gravity we stick to is a 9.81, huh? Yeah? Okay. So that's the relationship between specific weight and mass density. So you want, for lack of a better term, to memorize and know these symbols. Because sometimes in an exam, we won't even say the specific gravity of this fluid is this. No. We'll just give you the symbol and the value. So we would like to believe that you know what that symbol really means. And that's a relationship there. Okay, so we move on. The other really important property of a fluid is what we call relative density. The third one is called relative density. So the third one is relative density. But then sometimes it's also called specific gravity. So know this terminology so that when one is given to you, you don't go like, nah, it's the other one. Okay, they can be used interchangeably like that. And how do we define this? So just write this definition. Can someone switch on the lights there? It doesn't have. What? What time is this? In the next 10 minutes, some of you I won't be able to see you. Or you won't be able to see me. And the video, yeah? Actually, for me, I'm more worried about the camera. Is that so, Wache? Chapakati paj. All right, so let's define what a relative density is. A dimensionless measure of the density of a substance. A dimensionless measure. A dimensionless measure. Are we there? A dimensionless measure of the density of a substance. A dimensionless measure of the density of a substance with reference to the density of some standard substance. With reference to the density of some standard substances. With reference to the density of some standard substances. Usually, so I said with reference to the density of some standard substance, usually water at 4 degrees Celsius. So, if we can say relative density, so they want you to compare 2 different densities. So density of that substance, let me just say sub, over a density of a non-substance. Usually this is of water, which is at 4 degrees Celsius, so of water. Also remember the definition says it is dimensionless. This means that it's got what units? It's unit free, it's unitless, not so. Pay attention to this because I've marked so many papers where still people put units to something that's not supposed to have units. But then this also means that you can have the specific weight of a substance divided by specific weight of water. And that's how you relate. Meaning mass density of a substance over mass density of water. Ladies and gentlemen, these 3 properties are interchangeably, no, they are connected. Are we together? So if I'm saying this is relative density, meaning in one formula, I have property number 1 that we discussed, which is mass density. I have property number 2, specific weight. I've got property number 3, relative density. So what you want to know is know the 3 of them, know their symbols, know their units, and know how they're related to each other. There's always a question around this. So just from class number 1, you have the knowledge to go and answer 1 question at least in any past paper as long as it's got this question. Okay? So let's do a very quick example, which I usually give as an assignment, but I'm feeling like giving you a different assignment. Simufuna assignment. Mufuna chizidi che. Mufuna quiz. Okay, let's do this. Just in the next, how many minutes do we have? 5 minutes, still fine. So I'm going to dictate this example, write it down. We're going to solve it. By the time we meet on Thursday, I want you to come back with a solution to the assignment I'm going to give you today. Something very basic and very similar to what we're going to do right now. So pay attention. If 6 cubic meters of oil weighs 47 kilonewtons, if 6 cubic meters of oil weighs 47 kilonewtons, comma, if 6 cubic meters, you know how to write a cubic meter, right? Yes. Okay. Just checking. Just checking. If 6 cubic meters of the weight of oil weighs 47 kilonewtons, comma, find its specific weight, mass density, and relative density. Find its specific weight, mass density, and relative density. Are we good? All right, so solution. So first of all, notice that in that, okay, I put it here, but when you go and look at the module, it only says specific weight, density, and relative density. When the density is just standing on its own as density, it means mass density. Are we together? Yes. So it will be given to you as density or mass density. So I just wanted to bring that to your attention. So what we've been given, one, you collect what's available, not so. So volume is 6 cubic meters. They've also given us the weight, okay, as what? 47 kilonewtons. From these two, what property can we get? Fast. And think of it in terms of the units that are there. If we put kilonewtons over a cubic meter, what unit are we going to get? Fast. If we put a kilonewton on top of a cubic meter, what property are we getting? Specific weight. See, the one who say that is paying attention. So from the units, you can know already what you're going to come up with. Why? Because we defined for specific weight, we said it's the weight, okay, over a volume. And the volume has been given, or the weight has been given as a 47 kilonewton. Don't throw away the units when you're solving over a volume which is a 6 cubic meter. This, a kilonewton over a cubic meter, is a measure of unit of a specific weight. And this, like I said, is your specific weight. Are we together? And notice how already, instead of writing specific weight, I just went direct to the symbol. So know what that property is, know the symbol associated with it, and know how it's related to the other properties. So, can someone divide 46 or 6 into a 46? Okay, let me do this. Thank you. 47 divided by, so I'm seeing a 7.8. What are the units? So it's going to be a kilonewton per. So question 1 solved. I can move on to question number 2 and find my mass density. Why? Because there was a formula that was given, and we said specific weight of a substance is equal to mass density by. These are the basics of everything you're going to do in this fluid mechanics course. And if you miss it here, it's going to be hard. So if whatever I'm talking about right now just sounds like, what's that word again? Gibberish. Please find time between now and tomorrow to fully understand what we're doing here. All right? So this guy, we already have him, yeah? And the gravity we have. This we can make the subject of a formula. Did I mention that we picked people that were really good in math? No? If you didn't know, you guys are in the class of the elites. So you're good in math, and that's how you made it, huh? So things like making the subject of what formula, it should be easy. So mass density of this substance, which is oil, is equal to specific weight, which has been found, 83, divided by So divide this by 9.81, and the value I'm getting is a 0.79, maybe say 9. What are the units for mass density? What are the units for mass density? So it's a kg per cubic meter. We have found two solutions to what we've been asked. The third one said find the relative density. Relative density. And relative density, if I can use that abbreviation, is just either the mass density of a substance over the mass density of water, yeah? Or it could be the specific weight of a substance over the specific weight of water. But I'm going to go with the mass density of that oil over the mass density of water. So, what is the mass density of oil? So 0.799 divided by, what is the mass density of water?
1,000 kilograms.
If you don't know where these values are coming from, please just take your time, go back and understand where everything is coming from. Because already we have seen things are just sort of popping from everywhere. So if we divide this by 1,000, you're going to get our 7 point what?
799.
799. Are you sure? Zero point what?
0.0079.
So the power 4.
0.000.
To the power what?